preparation of a solution of cobalt chloride in a 100 ml volumetric flask. There are a couple of steps here. One of the first steps is we need to know approximately what mass of cobalt chloride we'll need to measure or weigh in order to prepare the solution. So I've done some rough calculations and have come to the conclusion that I'm going to need about 0.1 grams of this cobalt 2 chloride. And so you're going to join me right now in the balance room where I'll measure out approximately 0.1 grams of this cobalt 2 chloride in my weighing boat. Okay, so here we are in the balance room. We're in front of an analytical balance that reads to 4 decimal places, which is the sort of precision that we need in order to prepare our solution. Now right now the balance is reading 0.000 grams. What we want to do is tare or zero our weighing boat so that we're not including its mass in measuring our cobalt 2 chloride. So I'm going to open up the side panels, close the side panels. Now keeping the panels closed avoids air drafts running across the pan of the balance. I'm going to click tare. And now, of course, the balance is reading 0 with the weighing boat in there. Now, we might be tempted to start adding our chemical directly to the weighing boat, but it's best to remove the weighing boat and add our chemical here on the bench. This avoids getting the pan and the innards of the balance contaminated with chemicals. I'm also careful not to push down on the pan, because if I push too strongly, or if I push at all really, it could damage the balance. So I'm taking a small sample of the cobalt 2 chloride. I'm going to put this now into the balance. And right now I can see that it's reading 0.07 grams. So of course I need to add more. So once again I'm going to open up the side panel, remove the weighing boat. Now I said I want 0.1 grams, but I'm not going to spend hours and hours getting it exactly to 0.1000 grams, but rather I'm going to get something near 0.1 grams. And as I mentioned before, I'll do the appropriate calculations to see exactly what concentration of solution I've prepared then. So I can see that the mass is now reading 0.28 grams. I'm going to record that in my lab book. And so now we're ready to go back to the lab bench and prepare our solution. Okay, so we're now back at the bench. We're ready to make our solution, but there are a number of preliminary things that we'll need to do. It's a good idea to always assume that any glassware that you're working with is essentially still dirty. And so we'll do a little bit of rinsing of this glassware. But I should also explain why we have a couple of pieces of glassware in front of us. So we have here our powdered cobalt 2 chloride. I've recorded the mass. Effectively, I want to transfer all of this powder into my volumetric flask. Now, of course, I could attempt to just tilt it in, but I'm likely to spill it. So the idea is I'm going to make a solution in this beaker initially, making sure that I'm nowhere near the 100 ml mark. And then I'll transfer this solution into here, as it's easier to transfer quantitatively a liquid solution. I'll do a couple of washes and things. So therefore, I'm going to need to rinse out both my beaker and my volumetric flask. So starting first of all with my beaker, and the magic number here is rinsing 3 times, and small volumes of rinsing more effective than one large volume of rinsing, for instance. Okay, so just rinse this beaker a few times. These precautions will ensure that your solutions are as pure and accurately determined as possible. It takes a little extra time, but the time is well worth it in the end when your results are more effective, appropriate, So one of the other precautions that we're going to take is I'm going to dry the beaker here. And so magically a paper towel has appeared. Okay, so that you can assume the paper towel is going to be relatively clean. Okay, so I think this beaker now is ready to make my intermediate solution. So now I'll do the same thing, that is I will rinse out the volumetric flask. Understand that it's quite okay that in the end I can't completely dry the volumetric flask, in that it's okay to have some water in here as we prepare our solution. Because of course the volume of our solution will be determined by the graduation mark here in this volumetric flask. So once again, 3 rinses. Now, because this is just a matter of demonstration, I'm only going to do 2 rinses so that you don't have to sit and watch me do 3 rinses throughout. Okay, so that was the first rinse. Now the second rinse. And I think I'm ready to start to dissolve my powder. So I want to make sure that all of this solid gets from the weighing boat ultimately into the beaker and then finally the volumetric flask. And so I'm going to transfer all the solid into the beaker. And of course there's going to be some residual solid in the weighing boat as well. So I'm going to wash that solid into the beaker. Of course you want to try to avoid dropping your weighing boat as you're doing this. I don't think I lost any in doing that, but try to avoid dropping it. So a couple of rinses of the weighing boat. Now one of the nice things about preparing this particular solution is cobalt 2 chloride in water has this lovely pink color. So you can see that here. And so one of the things that you'll want to verify is that you've added enough water to completely dissolve the crystals. And as far as I can tell, all the crystals have indeed dissolved. And so now I'm ready to transfer this solution into my volumetric flask. Again, I want to make sure that that's a quantitative transfer. So making sure that the lip of the beaker is inserted into the orifice of the volumetric flask. I will transfer. Now, of course, it's very visible that there's some residual solution in my beaker. And so I'm going to do 3 washes of my beaker to make sure that everything within my power is transferred to the volumetric flask. First wash. Second wash. And again, because this is a demonstration, I'm going to leave it at 2 washes, but understand that I would do a third as well. Now I'm ready to fill up my volumetric flask to the graduation mark here. What I'm going to do is, so that this doesn't take too long, I'll take the knob on the end off, and I will add water a little more quickly. But of course, we always need to be careful in using a volumetric flask, because initially it may seem that the water is filling relatively slowly. But as we get to the upper end of the bulb bottom of the volumetric flask, the water level increases fairly rapidly. So at this stage, I'm going to put the end on and add a little bit more water now this way. As I'm approaching the narrow neck of the volumetric flask, I want to resort to using a pasture pipette to add the water. It's always a pain if you overshoot the level, because of course you have to start again. Now I'm bringing the volumetric flask to eye level so that I can see that the meniscus matches the graduation line in the volumetric flask. So we're almost there. Okay, just a little bit more. Okay, so because I've prepared this carefully and slowly, I'm confident that right now this is a solution of 100.00 mils. However, you may note that there's some liquid at the top of the volumetric flask, and it would be good to clean that out or dry that out a little bit. So I'm going to take a little bit more of my paper towel and just try to dab it inside. I may not get all the water, but certainly when I start to mix this solution, if that water is included, then of course I don't have a final volume of 100 mils. And again, I have to be careful not to touch the paper towel into the solution itself, because of course that would remove some of the solution. Okay. Now, one of the things that I haven't done is I actually should also rinse out the cap, because there's no guarantee that the cap itself is clean. Make sure you put the lid back on your water bottle. And I'm going to dry the cap, because once again, I do not want any more liquid in that volumetric flask. So lots of little precautions in making this solution to ensure that the concentration that I calculate is indeed the concentration of this solution, to the level of precision and accuracy as guaranteed by this 100 ml volumetric flask and the balances. Okay, so now we need to make sure that this is properly mixed. The method for mixing is you need to invert, shake, invert, invert, and shake. Now the shaking, along with the air bubbles, ensures good mixing. Invert and shake. Now that was done 3 times. That's probably enough to allow the solution to be mixed. And certainly having a colored solution helps us see that there's a uniform color throughout the volumetric flask. So these are the steps in preparing a solution, an aqueous solution of a solid. The idea, of course, is that you need to measure out a known amount of solid using your analytical balance, quantitatively transfer the solid to the volumetric flask, and then, of course, add the appropriate volume of water to reach the graduation level and mix.